This video will show you how to run a hypothesis test for a population mean. The example I'll be using is here. 10 years ago, the average age of AJC subscribers was 45. AJC wants to know if this number has changed, so not necessarily increased or decreased, they just want to know if it's different. They randomly sample 92 subscribers and report an average age of 48.6 years with a standard error of 2.02. So that's not the standard deviation, although sometimes you might be given the standard deviation instead of the standard error. So how can they determine whether or not the average age has changed? To do this, they would need to run a hypothesis test for mu, population mean. Step one of any hypothesis test would be to set up the hypotheses, of which there will always be two, the null and the alternative. The alternative, denoted H subscript A, is what the researchers are trying to show or prove or find out. So in this case, they want to know if the mean is now different than 45. And then in the null hypothesis, you just use an equal sign instead of an inequality. So this one, you'll always have an inequality, greater than, less than, or not equal to. And then in the null hypothesis, denoted H subscript 0, you always have an equal sign. Step two would be calculating the test statistic. This formula is in your formula sheet. It's a t test statistic, so y bar minus mu over s divided by the square root of n. So y bar would be a sample average, mu would be the assumed population mean, it's the value used in the null hypothesis, s is the sample standard deviation, and n would be the sample size. This term, s over root n, is the standard error. So in this case, we were given the standard error, so we can just plug that in there. So the sample average was 48.6. The assumed population mean was 45, and standard error was 2.02. So this gives you a test statistic of 1.7822. And if you check the description of the video, I'll put an interpretation of this value. What does that actually mean? So that's your test statistic. Step three would be calculating the p-value. So you want to plug the test statistic that you just calculated into the t calculator. Anytime the problem is about the population mean, you want to use the t calculator and then shade appropriately. So if the alternative hypothesis used greater than, you'd want to shade to the right. If it uses less than, you want to shade to the left. And if it uses not equal to, I'll show you what to do because I'm about to do it. Now, one thing to note is that the t calculator will ask you for degrees of freedom, which is just n minus 1. So in this case, n was 92, so degrees of freedom would be 91. Alright, so let's see. So here's the t calculator, change degrees of freedom to 91, and then our test statistic was 1.7822. So for a two-tailed test, what you want to do is shade such that this red chunk is small. You don't want to have this huge red chunk. You want it to look like this. So the p-value is not this. For a two-tailed test, you actually need to multiply that value by 2. So the p-value would be 2 times 0.039. Which would be 0.078. So that's the p-value for this problem. I will also include an interpretation of this in the description. And then your last step is reaching a conclusion. For any hypothesis test you ever run, your conclusion just involves comparing the p-value to a given significance level. For this problem, we'll say the significance level is 0.10. So there's no mathematical formula for this. This is just something that's given. It's usually something small, 0.1, 0.05, 0.01. But in this case, we have that the p-value is less than the significance level, and any time this is true, your conclusion will be to reject the null hypothesis. And then you would say there is sufficient evidence to conclude that the mean age of AJC subscribers has changed. So we're not saying what the mean age has changed to. We're just saying it is no longer 45. Based on the sample, we might think that maybe it's something bigger than 45, but that's not the conclusion. The conclusion is just that the mean age has changed. Also note that this part in brackets, that is what the alternative hypothesis says. So this conclusion, there is sufficient evidence to conclude that this is just the alternative hypothesis, and it looks like I missed a word. There's sufficient evidence.